my eye. So chapter 4 is on triangles, and it's mostly on congruency of triangles. So first, what we're going to do is go over classifying triangles. And today's stuff is stuff that you've seen before. Okay, most of you have seen this before. Classifying triangles by the angles, classifying them by their sides, stuff like that. So by our angles is what we're going to do first. So in this chart are all the different ways that we can classify a triangle by its angles. So the first one is an acute triangle. Okay, in an acute triangle, you have 3 acute angles. Okay, you have 3 acute angles in an acute triangle. Okay, so you'd want all of your angles here to be acute angles, so less than 90 degrees. Our next type of triangle is an obtuse triangle. Okay, in an obtuse triangle, you have 1 obtuse angle. Okay, not all 3, one obtuse angle. Okay, that is greater than 90 degrees. So a picture of that would be like this. And I could even label it, say that angle is 120 degrees. It is greater than 90, so that would be an obtuse triangle. Next one, what do you think it's going to be if you have 1 right angle? A right triangle. Okay, so right triangles have 1 right angle, meaning you have 1 angle that measures 90 degrees. Okay, so our picture here. Have to have 1 angle that has a 90-degree measure there. Okay, our last one, classifying by our angles, is equiangular. Okay, that means all of your angles are congruent. Okay, so if all of your angles are congruent, that means all of their measures are 60 degrees. Okay, so all 3 of those angle measures here would be 60. Now, I wouldn't call this an acute triangle, okay? It's not an acute triangle, even though all 3 of your angles are less than 90. It is more specifically an equiangular triangle because they are all the same. Does that make sense? Okay, so those are your 4 different classifications by angles. Now what we want to do is go over our classifications by sides. Okay, so now we're talking about the sides of your triangle. So the first type is a scalene triangle. Okay, that is when no sides are congruent. Okay, so all of your sides have different lengths. Ooh, that was a bad line. Okay, so here if I label these all differently. Okay, one side's 3, 4, and the other's 5. Okay, all 3 sides have different lengths. An isosceles triangle has 2 sides that are congruent. Okay, 2 sides that are congruent. So in my picture, I can use these dash marks. Okay, remember those dash marks mean that those sides are congruent to each other. Okay, so just those 2 sides are congruent. Last one is equilateral. What do you think that means?
3 sides congruent.
3 sides congruent. Okay, so all three sides of your triangle will be congruent to each other. Okay, meaning they're all the same length. Okay, you have to know the difference between classifying by your angles and classifying by your sides. Okay, so if I ask you to classify a triangle by its sides, and you say it's a right triangle because it has a right angle, that's wrong. Okay, I asked you to classify it by its sides. So you have to either label it as scalene, isosceles, or equilateral. Not just because, oh, I see a right angle, so it is a right triangle. That's classifying it by its angles. Okay, does that make sense? That's where I see a lot of mistakes on quizzes and tests. All right, at the bottom here, an equilateral triangle is also an equiangular triangle. So if you have an equilateral triangle, it must also be called an equiangular triangle when you're classifying it by its angles. So if all three sides are the same measure, all three angles have to be the same measure. And vice versa. If all three angles are the same, then all three sides have to be the same. Questions? All right, then flip it over. At the very top there, I want you to classify each triangle as acute, equiangular, obtuse, or right. So you're classifying these triangles by their angles. Okay, I want you to do 1 through 6. Okay, classify those triangles by their angles.
What's 2x times 2x?
4x squared. Why are you multiplying 2x times 2x?
I don't know. It's really easier.
All right, number 1. How would you classify that triangle? Yeah. It's equiangular. Number 2. What type of triangle is number 2? I know you know it. Obtuse. What about number 3? Right. Has a 90-degree angle. Number 4. Acute. Number 5. Obtuse. Last one, number 6. Acute. Okay, so again, that's classifying your triangle by its angles. Okay, next we're going to classify triangles by its sides. Okay, so we're either going to label it as equilateral, isosceles, or scaling. Those are the only 3 options you have. Now, before you start, I want you to put your pencil down. Put down. I want you to sit here quietly. Don't talk to the person next to you. Look at the picture and think about what it's labeled as. Or what you can see in that picture. All right, somebody raise their hand and tell me what they see in that picture. What's labeled in that picture? Justin?
Congruent side lengths.
Congruent side lengths, right? So I have these dash marks in all my sides. What length are each of those dash marks? 8. So I would go through and label all of those sides that have a dash mark as 8. So you know what they are. Okay, now using that information, I do want you to go through and do 7 to 10. Okay, 7, 8, 9, and 10. Remember, you only have 3 options to label these triangles. Either equilateral, isosceles, or scaling.
Yeah, what you do. If you want to see that I actually. Wait, this one, do they get those? Or not quite?
That's right. All right, so we're going to go over 7 to 10. Okay, 7 to 10. So number 7, we have triangle A, B, E. So that's these 3 sides here. One side is 8, the other is 9, and then the other one is 8 times the square root of 2. Those are all different. Okay, since all those side lengths are different, this is a scaling triangle. Okay, remember you're looking at side lengths, not the angles. Okay, number 8, we have triangle EDB. Okay, so we have one side of 8, another side of 8, and then the last side is 8 times the square root of 2. So here I have 2 side lengths that are the same. Since I have two side lengths that are congruent, that is isosceles. Number 9, we're looking at triangle EBC. Okay, so here I have 8 square root of 2. Here I have 8. And then this bottom length here is 16 total. Okay, so all three of those sides are different. So again, this is scaling. Okay, so you need that total side length of EC, not just one piece of it. Okay, and then number 10, we're looking at triangle DBC. Okay, so here I have 8, 8, and 8. So all three of those sides are 8. They're all equal, so it is equilateral. Questions? On classifying your triangle. All right, then numbers 11, 12, and 13, we're going to use those different classifications to solve for side lengths of our triangle. So number 11, we want to find x and the length of each side. Okay, so you have to find x and the length. If triangle ABC is isosceles, what does isosceles mean again? Two sides congruent, right? And it is giving us which two sides are congruent to each other. Okay, so AB, that's this length, is congruent to BC, that's this length here. Yes, I know it doesn't look like it is congruent. In geometry, you're going to learn very fast that your picture is never drawn to scale. Okay, so I'm given that these two sides are congruent. If they're congruent, what could I do to find the value of x? Those sides are congruent. What? We can set them equal to solve for x. Okay, so if they are congruent, they are equal, so set those measures equal. From here, you just solve for x then. So I'll subtract 2x, add 3, and divide by 2. Okay, so that's one part of my answer. X is equal to 4. I also have to find the length of each side. Okay, so I have to find the length of AB. So to do that, I just found what x is. Okay, it's 4. So I can plug 4 in for x here. Okay, just plug in 4 in for x. So we have 4 times 4 minus 3. So 4 times 4 is 16. Minus 3 is 13. Okay, I also need BC. Now, since I already know AB is equal to BC, what's the length of BC going to be? 13. They should be equal. Last side is AC. Again, just plug in 4 for x. So we have 4 plus 2. That's 6. Okay, so that's the second part to my answer there. Okay, questions on number 11. All right, I want you guys to do 12 and 13. Yep, you just got to find the length of each side then, too.
Yeah, it's 37.
Oh, yeah, okay. I didn't see that. Yep, that's right.
Thank you.
Yep. Okay. Can I go get a drink first? Yeah. Make sure you guys find the length of each side as well, not just X. Yeah, show me.
Check off the way. Yeah.
It's not that long, it's really short.
I'm trying to preserve my energy. And like walking back
Preserve
just uses
your
so much.
energy.
Has to check it over, doesn't trust me.
I
I'm very hurt by that.
very hurt.
I made it.
All right, I need somebody to write the answer to number 12 on the board. Show your work, please. Same thing with 13. Those of you who already got your assignment, you should probably be the ones
I'll do 12.
doing those ones. Oh, you can write it on the front one too if you want.
Right here?
It's fine.
4x plus 1. 5x minus 2.
Silent method.
Yeah.
I just thought they were equal.
Yeah, I can't.
5x,
No.
I
five
thought
x
so.
minus.
Other one, I have 5x and 4x. Thank you. I can't see. This is equal.
Okay, I was looking.
Yes.
I know, I like put like this one on the sugar in there. Let it dissolve. But I already picked one of these. That's good. Well, you work in the genius part. How do I get my computer? Oh my god, it's turned out. I've been trying all morning.
How did you get that done?
All right, so coming together here, number 12. Justin, you want to explain what you did here?
Yeah, number 12, it's an equilateral, so I just took two sides, put them equal together and solve for x, and then I plug it into one of them, and then because it's equalateral,
Everybody here? Yeah? Okay, so since it is equilateral, you didn't have to pick the same two sides that he did. Okay, you could have set 3x plus 10 equal to 4x plus 1. Okay, or 4x plus 1 equal to 5x minus 8. It's equilateral, it doesn't matter which two sides you set equal. Don't set all three equal though, because then you're going to get confused because then you have two equal signs in your equation and you're going to get all lost and out there. Okay, so all three sides should be 37. That's correct. You want to explain this one?
Yeah, sure. So it's a isosceles triangle, so RX plus 2x. So we just set 9x plus 2 equals 6x plus 8. So then you get x equals 2 and then you get 3.
Good. Okay, so that one was isosceles. Gave you which two sides are congruent, set them equal, solve for x, plug it in. Okay? Questions on those two problems? Most people who showed me that they finished them and got their assignment early, they were all correct. Make sure they were correct before I give you your assignment. Okay? Good? You have to set them up. So instead of it giving you equal to this, it's giving you side m with 2 less than 5 times x. So it's 5 times x. Yep, and it's 2 less than that.
No, the abstract is the abstract.